Hello everyone. In today's video, we are going to talk about Bayes' theorem in probability, and we're going to do some problems based on Bayes' theorem. Okay. So before we start Bayes' theorem, first let's talk about what is the statement of Bayes' theorem. Bayes' theorem is saying that if I have n events, let's say a1, a2 till an, I have n number of events, and the first thing is all these n events have to be pairwise, mutually exclusive. Okay, pairwise, mutually exclusive. So if all of them are pairwise, mutually exclusive, now what does this terminology mean? Pairwise, mutually exclusive. This means that if I take any of the two sets, okay, if I take any of the two sets, let's say one of them is AI and another one is AJ, then they do not have anything common in between them. Okay, something common means having a set like this. So they don't have anything common in between them. So pairwise mutually exclusive means AI, AJ, which actually means the intersection of the two sets or the two events, the intersection of the two events is 0 for any I not equals to J, right? So if I have n number of mutually exclusive events, and number two, all these events, this entire set of events, this has to be exhaustive set of events. That means a1 plus a2 plus dot 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 an, the union of all the events has to be equal to the entire sample space capital S. Okay, if I represent it by capital S, then in all the events a1 to an, it forms the exhaustive set. Okay. Now, if these two things are satisfied, Bayes' theorem is saying that if I take any random event from the set of events, let's say capital X, if I take any event capital X associated with that experiment, not necessarily from a1 to an, any event associated with that experiment capital X, then probability of AI given X is probability of AI into probability of X given AI whole divided by summation R equals to 1 to n probability AR into probability X given AR. Okay. So this is what Bayes' theorem is telling us, and this is going to hold for any I equals to 1 to n. Okay. So if I choose any one of the events, a1, a2, an, any one of the events among them and call it to be ai, then for that particular fixed value of I, probability of AI given X is represented by this kind of an expression, and this is called Bayes' theorem. Okay, so this is Bayes' theorem. So one thing we need to keep in mind, that the X thing that we are taking, the X event that is happening in that experiment, probability of that should be specifically non-zero, right? Because if it is 0, it's going to create a problem here. The probability is going to become undefined, right? So probability of that experiment X has to be non-zero. So now this is the statement of Bayes' theorem. Let's take a look into one of the sums. So this is one problem that we have. This is a very important problem. This question has come in Calcutta University in, I think, 2011, and a similar kind of question, similar type has come in 2020, right? And it has come in many other exams also. So the question is saying that from an urn containing 5 white and 5 black balls, 5 balls are transferred. Okay, so we are transferring 5 balls into another second urn from which 1 ball is drawn. Okay, so from the second urn, 1 ball is drawn and it is found to be white, right? So what is the probability that all the balls transferred from the first urn are white? So that means the question is saying that I have two urns. Okay, this is my urn number 1 and this is my urn number 2. So the first urn is containing 5 white and 5 black balls. So there are 5 white and 5 black balls in the first urn. We are transferring 5 balls to the second urn, which is the empty one. Okay, so from here we are transferring 5 balls. What color we don't know. We are transferring to the second urn. Now, from which one ball is drawn. Okay, so now we are drawing one ball again from this urn. How many? One ball we are drawing. And this one ball that we have drawn, it is found to be white. Now it is asking that what is the probability that this transfer that we made, the 5 balls that we transferred from the first turn to the second turn, all these 5 balls that we had transferred, all these were white. And what is the probability of that happening? Okay, so we need to find this. So let us name the events. Let's say A0 is the event where all the balls transferred from the first turn to the second turn. What are the different possibilities? That all the balls transferred are white, or 4 of them is white, 1 is black, or 3 of them is white, 2 is black, 2 of them is white, 4 of them is, sorry, 3 of them is black, and so on, right? So A0, I'm saying that all the balls transferred from U1, okay, transferred from U1, all are white. Okay. A1, I'm saying that transferred from U1, 4 are white and 1 is black. Right. Similarly, A2, I'm saying 3 are white and 2 black. A3, 2 white and 1 black. And A4, I'm saying 1 white and, sorry, did I write that wrong? Sorry. So 2 white and 3 black, 1 white and 4 black. And finally, all black. Okay, all the balls transferred are black. So these are the possible 6 scenarios that can happen. A0 to A5, 6 scenarios that can happen. Right? Now what we got to find out is, it is given to us. This is given. Okay. It is given to us that the final ball that we are picking up from the second turn, that is white. So that is given. So I'm saying that X is the ball from urn 2. Okay. The ball from urn 2 is white. Okay. So this particular thing is given to us. It's given in the question that this last ball that you're taking from urn 2, that is white. So what we need to find out that these 5 balls which are transferred, that is also 5. So what we are trying to find out here is what is given to us. X event is given to us. So the given one is X. And what we are trying to find out, that all the balls transferred from the first turn is white. So that means this A0 case, right? That all the balls transferred from U1 is white. So they will find out the probability of the event A0 happening, given that X has already happened. Okay. Or I should reframe my sentence that we are trying to find out that if it is given that X is happening, then what is the probability that A0 is going to happen, right? So we are going to apply Bayes' theorem over here. So just by the formula that I gave you, Bayes' theorem would be probability of A0 into probability of X given A0 whole divided by summation R equals to 1 to, here I shouldn't take R1 because my enumeration you can see my enumeration is starting from A0, right? So the index is starting from 0 and going up till 5. So I should adjust my index out here also. So I should write it from R equals to 0 to R equals to 5, P of AR into P of X given AR, right? So this is the formula which I just stated in base theorem. So now if I break the denominator part, if I break up the denominator part, P of A0, P of X given A0 by, if I break up the denominator part, I'll have P of A0 probability A0 into probability X given A0 plus probability A1 into probability X given A1 plus probability A2 into probability X given A2 plus probability A3 into probability X given A3 plus probability A4 into probability X given A4 and finally probability A5 into probability X given A5. So this is my entire denominator that I need to calculate. So now I need to calculate all these probabilities one by one. Okay. So I need to know all these probabilities. Only then I can put their values. That's it. So again, we need to refer to the question for all this information. So first, let me concentrate on probability of A0. Okay, let's go back to the question. What was A0? A0 was transfer from first urn to the second urn in such way that all the balls transferred are white. So that means I'm transferring 5 white balls from urn number 1 to urn number 2. So what will be my probability for that? So I'll just write the probabilities over here. So probability of A0, this would be, I am transferring all 5 white balls from the first to the second. Now, how many balls are there in the first turn? There are total 10 balls, right? 5 white, 5 black. So out of the 10 balls, I'm selecting how many balls? 5 balls, right? And so this is my total possibility of selection. Now, how many white balls are there? 5 white balls. And how many white balls I want to select? I want to select 5 out of those 5, right? So I want to select 5 white balls out of the given 5 white balls, right? So this is my probability of A0 event, right? Then probability of A1, that would be how much? Now I want to select, what was A1? 4 white balls and 1 black ball, right? So how many white balls are there? There are 5 white balls. So out of the 5 white balls, how many I want to select? I want to select 4 white. And how many black balls are there? There are 5 black balls. And how many black balls I want to select? I want to select 1 black ball. And the total possibility remains same because ultimately I'm again choosing 5 balls only. Similarly, probability of A2, that would be out of the 5 white, now I'm choosing 3 white balls, right? So 5C3, and out of the 5 black balls, I'm selecting 2 black, so 5C2, and total probability, total possibilities remain same, 10C5. So similarly, this will go on. You can understand how this is working. So this is going to be P of A3 if I want to find out. So that would be 5C4 into, sorry, this is going to be 5C2 into 5C3 by 10C5, and probability of A4, that would be 5C1 into 5C4 by 10C5, and finally probability of A5, that's going to be 5C0 into 5C5 by 10C5, right? So these are all my P of AI probabilities, right? So these things are done. I found out P of A0. I have found out P of A1. I have found out P of A2 and P of A3, P of A4 and P of A5. So what are the remaining things? X given A0, X given A1, X given A2 and so on, right? So I'm going to do that calculation right over here, just below this line. So probability of X given A0. Now what does this mean? This means given that the A0 experiment or A0 event has happened, what is the probability that the X event will happen? What was A0? Selecting 5 out of 5, right? 5 white balls out of the 5 white. And what was X? Just remember what was X? X was the ball from urn 2 is white. That was my capital X, right? So I'm just going to elaborately explain to you this particular one. The rest of the things you can do it on your own. See, if from urn number 1 to urn number 2, I have 5 white and 5 black. If I transfer all the 5 white balls into urn number 2, because A0 is my given event. Okay, so if A0 event is happening, that means I have transferred all the 5 white balls. Now the question is, from here I want to select one ball and I want that to be capital X event. That means I want that to be a white ball when I am picking it from the second urn. So what is the probability of this happening? So if I want to select one ball from one white ball from 5 white balls, how can that happen? I have 5 white. So out of the 5 white balls, I can select any one of them. And that is the total possibility. And again, what is my favorable case? My favorable case is again out of the 5 white, I'm selecting any one. So it's going to be 5C1 only. That means total probability, it's 1. Right? Because if I have 5 white balls in an urn and I tell you to pick any one out of it, obviously a white ball is going to come out. There is no alternative way that any other ball will come out. Right? Similarly, X given A1, that means now in this case, what has happened? A1 event is given to us. The event A1 has happened. So according to the event A1, 4 white balls are transferred and 1 black ball is transferred, right? So now in my second urn, I have 4 white and 1 black. Out of these balls, I want to select one ball and I want it to be white, right? So what is my total number of possibilities? I have total how many balls? 4 plus 1, 5. I have total 5 balls. Out of them, how many I'm picking up? I'm picking up 1 ball. So denominator remains same. Now, how many white balls? I have 4 white. And out of them, I am selecting 1 white. So that means 4C1. Similarly, probability of X given A2 will be how much? Now I'm transferring 3 white and 2 black. So that means out of the 3 white, I want to select one of the white and the denominator remains as it is. Similarly, probability of X given A3, that will be, now I have 2 white. So you can see this is decreasing. This was 4, then became 3. Next is going to become 2C1 and denominator is going to remain same. Then probability of X given A4 will be 1C1 by 5C1, right? And finally, probability of X given A5. So that means in A5 event, what was happening? That I was not transferring any white ball at all. So that means probability has to be 0. If I'm not transferring any white ball, how can I pick up one white ball at the end? So that means it's basically, this is going to become 0. The numerator part is going to become 0. So that means it's just going to have 0 because that event is not possible to happen because I have not transferred any white ball. So how can I pick up a white ball from the end, from the second urn, right? So now we need to plug in all these values. Okay, this one, this one, this one. Okay, all these values, we need to plug it into this equation that we had. along with all these values as well. Okay. So all these values are all going to get substituted over here from my left hand side and from my below. Whatever things that I've calculated, all these are going to get plugged in right over here. Okay. So if I plug in all the values, that is going to give me my final answer. Okay. So I'll just stop for a few seconds here so that you can put the values, do the calculation, and then see what answer you're getting. So I'll just pause for a second here and let's see what answer you get. So I hope that you people have got the answers, broke up all the simple fractions that you have got. If not yet, then please pause the screen right now, do the calculation, and then see the answer which I'm going to show right now. So now if you have got your answer, then you can verify that whether these are the values that you're getting. Probability of A0 to A5, these should be the values, and probability of X given AI, these should be the values, the combinations which I had written before. So you can just take a screenshot of this and you can just see whether your answer is matching or not, these answers. Okay. So if you plug in all these values to the Bayes theorem problem that we had constructed, right? This was the Bayes theorem problem that we had constructed. All these values, if you're plugging over here, then the answer you'll be getting is 1 by 126. So I am not going into that calculation, that you can just verify it on your own. So this will be the answer to this problem. I hope I could make you understand the question.